video number 4. It's the last one in the series, and hopefully this will wrap a lot of things up for you so that as you've been working through your trig booklet from school, you'll have a chance to have used what you found out in these videos to help you complete the booklet. Now this one is all about finding the angle, and there's a little bit of a trick in it having to do with your calculator. So we'll do that when we get to it, but first of all, let's review the steps that we know so far. All right? We know, number 1, that we label the triangle from theta. That's the first thing we do. So if we were to label this guy, what do we call that? You're right, that's the opposite. I know, I heard you. Opposite, right? Now, if we're looking for the hypotenuse, it's always the longest side of the triangle. It's always opposite from the square corner. So that's our hypotenuse. So the last one has to be adjacent. Adjacent is the one that's kind of connects theta to the right angle. That's adjacent. Okay, so we know that. So number 2 was to choose the correct ratio, sine, cosine, or tangent, and then do the math. All right? Now, if you don't remember the trig ratios, don't worry. Even on a test, we give them to you. Back in the old day, they would have had to have had your mums and dads memorize it, but we don't have to do that because we want to know if you know how to use it. Okay? Now look at Grumpy Cat. How do we find the angle? And you know what? This guy's just so grumpy. He's like me without coffee. Well, the idea is that's what we're going to find out. All right. So it's pretty easy. We already know a lot like labeling sides, choosing a trig ratio, and looking good. That was my old math teacher, okay? Okay, but first of all, what we got to do is remember these 3 buttons, sine, cosine, and tangent. Well, the problem is, instead of turning an angle into a decimal like we did with the other ones, we have to do the opposite. We have to turn a decimal into an angle. And to do this, we have to use what's called the inverse operation. Now, that means the opposite, or kind of the upside down version. What that means is we want to do what's up here in these pink spots. So sine will take an angle, turn it to a decimal. Sine -1 is kind of like the inverse, and it's going to take that decimal and turn it back into an angle for us, which is what we're looking for. So here, well, let's have a look at this this graphic. Now here are your sine, cosine, and tangent buttons, all right? Now, here's a quick little idea, is to get the angle, press inverse, second function, or shift to get those inverse ratios. Now, you probably want to hit inverse and then sine, okay? Or inverse and then cosine, or inverse and then tan, in order to get a decimal turned back into an angle. Now, just an idea, a lot of kids get into this idea. Now, how come I'm getting the wrong answer? I'm doing everything right. Well, that's because up at the top of their calculator, it should say in little letters D, E, G for degrees. Sometimes calculators get into things called radians. All right, so we want to be in degrees, and keep your eyes open for that. Okay, now let's go back to this example. I'm going to clean this up a little bit. Okay, so let's try this example from the top of the page. Okay, number 1, we're going to label the triangle. So let's just go back here, and I see from theta, I'm going over this way. So it's my opposite, and there's my square corner. So this way is going to be my hypotenuse, and so this has to be my adjacent. Good. Okay, so we're done that. Label the triangle. Yeah, I'm real good at that. Good. Okay, now we want to choose the right trig ratio to fill in the information. Now this is what we learned about before. Kind of the idea is, what don't I need? Well, I need this guy because it's got information. I need this guy because he's got information. Do I need hypotenuse? No. No question mark, no information. Hypotenuse, You're dead to me. Well, that's pretty... Anyway, we're going to use tangent, opposite and adjacent. Okay, so we're going to do the same thing that we did before. We're going to set up our ratio. So we're going to go tan is equal to opposite over adjacent. So my opposite was 18. That's supposed to be an 18. Oops. Divided by 18. Okay, so here I'm going to end up with tan is equal to 1. Now, what do I do in my calculator? So I'm going to go second function tan 1, and I'm going to get 0, or I'm sorry, I'm going to get 10, I'm going to get 30, or I'm sorry, 45 degrees. Good. So I've got a 45-degree angle. And all I did was put second function tan of 1 to 45 degrees. Okay, I'll clean this up a little bit because it looks like 0.45. So 45 degrees. Good. 45 degrees. Okay, so that was us doing the math. And the second function, your calculator might say shift, or it might say inverse. Let's have a look at what those actually look like down here. Okay, so a big caution. There are two different ways. There are two different ways in which a calculator may want you to turn a decimal into an angle. Now, one of them might look like a second function key. So you would hit second function sine, or second function cosine, or second function tan. That's all good. Or your calculator might say shift. So you would still go shift, sine, cosine, or tangent. Or it might say inverse, INV. And then you just do the that key, put in the decimal, hit equals, and it'll give you the angle. And remember, we always do an angle. So if we have an angle that says like 35.68 degrees, oh, that's nice and thick. We just go to one decimal place with an angle. So we would say 35, and in this case, 0.7 degrees, because it rounds up. So we usually, for angles, we usually go to one decimal, okay? If it says go to the nearest whole angle, well, then we would go to 36 degrees. All right, so let's do some examples. So like the previous video, we're going to use the same situation 3 times so we can use each of our 3 trig keys, all right? So, and this is going to show that each angle, each theta should turn out to be the same, all right? Now, I'm going to just spoiler alert. If we do the math right, we'll get a 30-degree angle. Why will we get a 30-degree angle? Well, because if we look at our last video, and here's the carnage from our last video, 30 degrees, 30 degrees, 30 degrees. So if trig be right, then basically we're going to get 30 degrees each time. Okay? Because we're using the same numbers. That's what I'm getting at. If we use the same numbers, then the ratio of those numbers will give us 30 degrees. Okay, so let's not get ahead of ourselves. First of all, what we're going to do is we're going to label the triangle. So this is theta. It's what we're looking for. So here we're going to go opposite. Here's my right angle. So this is going to be hypotenuse. And here's my adjacent. Okay? Now, I want to choose the appropriate trig triangle. Okay? So by appropriate, I mean, which one do I need? Well, check it out. This one has got information. This one has got information. Hypotenuse has got nothing. Nada. Zip. So I'm going to look for a trig ratio that's got an O and an A right there. Okay, so what I'm going to do now is the math. So I'm just going to go tan is equal to opposite over adjacent. So I'm going to tan is equal to 8.66 divided by 15. So in my calculator, so I'm going to go 8.66 divided by 15, and I'm going to get t is equal to 0. Well, that's supposed to be 0.57733. So what do I do in my calculator? Well, I'm going to go second function tan or inverse, whatever it is you have for a calculator, and I'm going to put in that decimal 0.57733, and guess what it's going to give me? Huh? Can you guess? Can you guess? Keep guessing. 30 degrees. Well, 29.99, so I think that works out to 30 degrees. That's our tangent ratio. The only thing we did different was we used a second function. Now, we didn't have to do Amazing Dr. Z because we didn't need Amazing Dr. Z because the math was all on this side. And t is just equal to it. So we didn't have to do any of that crossover stuff. So that's why Amazing Dr. Z wasn't needed, because we're just getting a straight up answer and we're going to convert it to an angle. Okay, let's look at the next example here. So what's the first thing we do? Let's label. Yes, you're right. So we're going to go from theta. And so this will be opposite. There's my square corner, hypotenuse, and adjacent. Okay? Now we want the trig triangle and the data. Well, the thing is, I didn't get the, oh, sorry, folks. I didn't get the data in there. What we're going to do, let's just add it. So this is 17.32. We know that from our other video, okay, 17.32. And we know that this was 8.66. Okay, sorry about that. So what we've got now is we've got information for our hypotenuse, and we've got information for opposite. What's A got? Huh? What you got, A? What you got? You got nothing. So we don't need anything with an A in it. So we're going to use sine. Okay, so back here. So we're going to go sine is equal to opposite over hypotenuse. So sine is equal to, opposite was 8.66 over 17.32. Now when we do that math, so 8.66 divided by 17.32, we're going to get sine is equal to 0.5. So now what do? Because an angle can't be 0.5. It just can't be. So we're going to use second function, sine 0.5. And guess what? 30 degrees. What's that? 30 degrees. What's that? 30 degrees. Amazing. Amazing. Okay. Now we're going to do the same thing with cosine. Okay. But like a good teacher, I didn't get this quite ready. So our hypotenuse was 17.32. Our adjacent, what do we have for adjacent from way up? Oh, 15. Okay. So our adjacent was 15, and we're looking for theta. Okay. So what's our first job? Label. So from theta, this is my opposite, this is my hypotenuse, and this is my adjacent. So even though I've done it several times before, you still want to do it each time because it's that trig triangle or that trig ratio that fits in with the labeling that does all the math. So you don't want to make a mistake. Okay, now we want to find an appropriate trig triangle for the data. Okay, well, let's look at data. Has O got anything that's useful for anybody at any time? Well, not in this one. So O, you're out of luck. So I'm not going to use a trig ratio with O, which means I'm going to use cosine. All right? So it's not that we're haters on opposites. It's just not useful to us in this one. So here we're going to go cosine is equal to adjacent over hypotenuse. Okay, so cosine, we're going to fill in the information now. Adjacent was 15. Hypotenuse was 17.32. Now, if we go 15 divided by 17.32, we get a decimal 0.86605. Okay, so what do we do now? Second function, Mr. Chambers. Get the second function, Kate. You'll love it. All right. Second function. Cosine, because that's the trig triangle we used, 0.86605. And drum roll, please. What do we get? You got it. 30 degrees. So I'm going to tell you, that's pretty cool that it works out each time. And each time we're only working with two different parts of the triangle. I mean, that's why trigonometry works, which is why they can tell where Google Maps is and your cell phone and all that kind of location data. It's all about trigonometry. Okay, now, in one of our earlier videos, there was an example of an airplane. If an airplane has an angle of attack, the slope as it climbs into the air, that is less than 15 or greater than 20 degrees, it will stall and fall from the air. Is this airplane safe? So this is an example of a real world kind of question that you guys would see, all right? So what are we going to do? Yes, number one, we're going to label. Okay, so from theta, this one is opposite. Here's my square corner. So this has to be hypotenuse. So the last one has to be adjacent. It just has to be. Whoops, too many. Okay, now, what are we going to do? We're going to choose our trig ratio. So choose, okay? So before we get there, let's see what we got. We got something for adjacent, and we got something for opposite. Who's got nothing? Hypotenuse. Hypotenuse, you got nothing. So we're not going to use you. So if we go back up to our trig ratios, let's clean this up. If we go up to our trig ratios, we don't want anything with hypotenuse in it because it's not useful to us. So not you and not you. You, tangent, opposite, and adjacent. Okay, so what we're going to do now is we're going to write down that trig ratio. So tangent is equal to opposite divided by adjacent. So tangent is equal to, and I see from our diagram, opposite is 300, maybe 300 kilometers, 300 meters. I'm not sure. It just says 300. Adjacent is 400. So now we're just going to do the math. So 300 divided by 400. Well, let me grab my calculator. 300 divided by 400 equals 0.75. So, is that a degree? No, it's a decimal. How do we turn it into a degree? Well, second function tan. Because we use the tan ratio, so we have to use the tan key. I mean, it's only fair. 0.75. Okay, so I'm going to go second function or shift or inverse. Hit my tan key equals 36.8 degrees. 36.8 degrees. Uh-oh. Uh-oh. It's more than 20 degrees, which means that plane is going to stall and crash. Somebody better radio to that airplane. Okay, so let's review for a second. All we've had to do is basically learn how to label a triangle, choose a trig ratio, and when we've done the math, turn that decimal into an angle by using our second function key or the inverse key or, whatever. And that's basically it. So I hope this helps you guys. This was the last video in trigonometry. This one was about finding the angle. The one before this was finding the side. The one before that was labeling the triangle. The one before that was, what is trigonometry? So hopefully now you've got the whole idea that trigonometry is actually a pretty cool math. A lot of people like it. And instead of being an angry cat, you guys might want to turn into being happy cat. There, see? Happy cat. Where do we use trigonometry? Carpentry, engineering, you name it. Trigonometry is one of the basic math sciences that we use to apply to the real world. And it frankly is one of the differences between swinging a hammer and being the Red Seal guy who oversees a job site, is being able to do this stuff. Anyway, thanks for hanging on with the ride. Hope you do well on your booklets. Give me a message if it's working out good. Give me a message if it's not. Anyway, good luck. Stay safe. Oh.